Well, good morning. We are looking at the extra credit problem for exam 2. So we're going to start at the beginning, make sure we read everything, make sure we don't miss any of the important elements. And what we're going to do is work through setting up the problem and answer any questions that you might have. And then I will let you finish up the problem on your own once we go through how to set it up. So we're doing support activity cost allocation, and it says Kizzle's Crepes Company produces world famous crepes. The company's crepes are produced via its mixing and cooking activities. Both rely on the janitorial and maintenance activities. So we have 2 production departments and 2 support departments. Kizzle's management knows the most practical driver of janitorial costs is square feet, but it is uncertain whether to allocate maintenance costs based on asset value of production equipment, number of service calls, or machine hours. Kizzle's management estimates that the cooking and mixing activities each require about twice as much space as the maintenance activity. So identify the base for choosing the cost driver. So as we look at maintenance costs, do you think we'll get to that in the second question, but identify the base for choosing the cost driver. So we need something that can be measured practically. We need to choose a driver that matches the department activity, and choose a driver that matches the support function. And so I think the best answer is probably all of the above, because all of those seem to make sense. That we'd want to, it has to be measurable, right? We talked about, you probably are aware of SMART goals. We need to have something that is measurable, and it should match what's happening and what these in the department and what the support department does for that production department. So as we look at the second question that's answered here, identify the driver which cannot be used as a cost driver for maintenance cost. So we know we're allocating janitorial costs based on square feet, but we're not sure how to allocate the maintenance costs. So we have asset value, number of service calls, or machine hours. Okay, so square feet, identify which cannot be used. We have square feet, number of service calls, machine hours, or asset value of equipment. And so the one that it did not.
Oh, I hate to interrupt. I'm sorry to interrupt, but I went to try open the extra crep. I accidentally just opened the real exam. I don't know what to do.
Okay, so looking at our second question here, identify the driver which cannot be used as a cost driver for maintenance cost. And the answer is that you would not want to use the same driver as you're using for the janitorial costs, because then you might as well just allocate them all at once, right? So you wouldn't be allocating them separately if you use the same cost driver. Oh, good. So if you wouldn't want to use the square feet, which is letter A, you would not want to use square feet, because it would not, again, if you use the same driver for both, you're not allocating them separately, you're allocating them together, which is the traditional approach that we learned back in chapter 16. So any of the other drivers that are listed, and those are the 3 that they had mentioned up here, any of those other 3 would be perfectly legitimate. And so the company simply needs to decide which one of those makes the most sense as the reason that one department might deserve more of the maintenance cost than the other department. So we'll move on to part 2 then. Assume that Kizel's management So number 2 says, assume that Kizel's management allocates maintenance costs based on the number of service calls. So we now know that maintenance is going to be based on service calls, which seems to make sense because maybe the cooking department has more breakdowns, has more need for maintenance than the mixing department. So to me, number of service calls is probably the most appropriate of the 3 options they gave us. Further, assume that in a given period, the janitorial, mixing, and cooking activities incur, these are the service call numbers, and janitorial maintenance costs are $3,000 and $4,200. We determine the total cost allocated from each support activity to the other 3 activities using the reciprocal services method. So we're going to allocate janitorial based on square footage. Where does it give us the square feet? Am I missing this? Where does it tell us square feet?
At the top, what I saw is that it says for cooking and mixing each require about twice as much space as maintenance.
Yep, perfect. That will do it. So we'll just use the ratio. Thank you. Good catch. So it tells us right here that I was just skimming and looking for actual numbers. So we'll be able to use the ratio that cooking and mixing are twice as much as maintenance. So we'll just use a 2 to 2 to 1 ratio, which actually keeps our numbers nice and small. Good catch. Okay, so we're using reciprocal services method, and you know that's why I made this the extra credit problem, because I told you that you were not responsible for being able to do this, but if you were able to do the reciprocal services method, there would be this extra credit available. So we have our total costs, $3,000 and $4,200. Those are the direct costs for janitorial and maintenance. But we know that each of those departments under reciprocal services is also going to receive an allocation from the other department. So let's start with setting up our equations. Okay. So I'm just going to use this open white space here so that I can scroll up and down if needed. So we'll start with janitorial, and I'm just going to abbreviate that Jan just for space purposes. And so the janitorial direct costs are $3,000, but we want to add to that a piece of the maintenance. And maintenance is going to be allocated based on our service calls. So how many service calls do we have? Add those up. So we have a total of 80 service calls, and the janitorial department is 16 of the 80, or 20%. So 20, whoops. Get that up a little bit so it's lined up. There we go. 20% of the maintenance. So our total cost for the janitorial department would be the direct cost of $3,000 plus 20% of the maintenance. But the maintenance cost is going to include its direct cost. Put that on the next line here. The maintenance department is going to include its direct costs given as 4,200 plus. So cooking, mixing take twice as much space as maintenance. So if we just assign them 2 and 2, and then maintenance is 1, maintenance is 1/5 or 20%, 1/5 of the total cost of janitorial. Janitorial is allocated based on square footage. So 20% of the total square footage, if we do 2x and 2x and 1x, that's 5x. And maintenance is 1/5, 1x out of the 5x. That's where the 20% comes from. Everyone okay with where those formulas come from, where those equations come from? So what we need to do next, and I'm going to ask you to try this on your own, what we need to do next is solve this system of equations by plugging one into the other, because we can't solve our system with 2 variables. So what I would suggest you do is take this and plug it in for this maintenance, and then simply solve for janitorial, and then you can plug that number back in and solve for maintenance, and then you're ready to do the allocation. The last question then is, the company is considering changing from the reciprocal service to a simpler method. Why should the company continue with the reciprocal service method? And let's read through these answers. It is complex but more accurate. That's definitely true. It can be practiced if the company has sufficient resources and capacity. The simpler cost allocation methods are less accurate. And since A and C are both true, then the answer, without even answering whether B makes sense, we know the answer has to be all of the above, because A and C was not an option. I'm going to pause the recording at this point. Oops, maybe. So once you have that system of equations solved, you'll have a total for janitorial, you'll have a total for maintenance, and you're going to use this information to allocate the maintenance department. So we already said that janitorial, oops, get my, right here. We already said that janitorial is 20% of that. It's 16 of the 80 calls. The mixing department is 40 of the 80 calls, so it's going to get 50%. And then the cooking department is 24 of the 80, so that must be the remaining 30%. And based on the 2 to 2 to 1 ratio that we were given at the beginning, maintenance is going to get 20% of the janitorial cost, while mixing and cooking are each going to get 40%. So once you solve this system of equations, you have a total dollar amount for janitorial and for maintenance. You can then allocate based on these percentages. Okay, so we just discovered using the check my work button that it did not like my answer of square feet for this second question. And you can see using the guess and check method that the answer it wants is asset value of equipment. I personally have an issue with that because of the way this is termed, which cannot be used. And the explanation provided by the textbook for the reason asset value cannot be used is because it's not a good estimate of the actual maintenance cost. The reason that one department might use more maintenance than the other doesn't. But the question isn't which one shouldn't be used, but which cannot be used. So I'm sticking with my answer that square feet is the best answer, simply because it generally would not make sense to use the same driver for both of the support departments. However, to get credit for this, you need to give the answer that it wants, which is asset value of equipment. But again, it can be used, it just shouldn't be used. So I wanted to clarify that. So we're now going to look at the chapter 20 problem. We just finished chapter 20 in class yesterday, and so we'll take a look at this chapter 20 problem with the time that we have left. This problem, of course, is on CVP, or cost volume profit analysis. The first section is on cost behavior. Cover to Cover Company is a manufacturer of shelving for books. The company has compiled the following cost data and wants your help in determining the cost behavior. After reviewing the data, complete requirements 1 and 2 that follow. So the first thing we have to answer is, are these costs variable, fixed, or mixed? The easiest one to identify is the one that is fixed, because the cost remains the same regardless of how many shelves we produce. So 14, 28, 56, and 70, they all have the same cost for total machine depreciation. So we know that is a fixed cost. Now the other two might take us a little bit more work to figure out. So the easiest way to check this is to see, as we go from 14 to 28,000 shelves, does the cost double? Is it double the number of shelves? Is it double the cost? And it looks on the face of it like they might both be variable costs. Okay, so as we went for the total lumber cost, as we went from 14 to 28,000 shelves, the total cost did double. And so that tells us that is purely a variable cost. In other words, the y-intercept is 0. So if you think about how we talked about using the high-low method and separating fixed from variable cost, if it's completely variable, then the cost at 0 shelves would be 0. And so in that straight line where the slope of the line is the variable cost, if we double production, our cost should double. But that's not what happens here with the total utilities cost. The total utilities cost does not double when we double our production. So that tells us that this is a mixed cost. If you have a question about this, go ahead and unmute and ask your question. Number 2 says, for each cost, determine the fixed portion of the cost and the per unit variable cost. So depreciation, we know, is a fixed cost completely. So the entire amount must be the fixed cost, and there is no variable. For the lumber, it's exactly the opposite. It is purely a variable cost, so there is no fixed cost, but we need to find the variable cost per unit. You can use any one of the levels of production. Divide the total cost by the number of units produced to get the cost per unit. And then for the utilities, we're going to have to use that high-low method. So we can take our high point here and our low point here and use the high-low method to separate the fixed from the variable. So we start with finding the slope. We know that the slope M is the variable cost per unit, the way we discussed it in class. And we know how to find slope. We take the change in Y's. The Y is the total utilities cost. So our high point is 82,000, the low point is 17,600. And we divide by the change in X, that's the number of units. Everybody okay with that variable cost per unit?
Could you go over how you came up with the 11 once more for the variable cost for lumber?
Yep, absolutely. So for the lumber, whoops, let me get my annotate back up here. So for the lumber, we can take any one of the four production levels, 14, 28, 56, or 70,000. It doesn't matter which one you use. And so I just took the lowest one because that gives me smaller numbers to work with, and that's just easier. So I started with the $154,000 that it cost us to make 14,000 shelves. And that's the $11 per shelf.
Yeah, got it. Thanks.
Let's just label this now. This is utilities. And now the last step for utilities then is to find the fixed cost. And the way I had suggested that you do it in class is by using the slope intercept form of the line. But I also said you can do it. You don't have to think of it that way if that's not beneficial for you. And so we could just use the, use the formula. So the fixed cost will be the total cost. And again, we can use any point, either point, either the high or the low point. So I'm going to use the low point just because it gives us smaller numbers to work with. So the fixed cost would be the total cost minus the variable cost. And we already calculated the variable cost to be $1.15 per unit. And that's for 14,000 units. And I got $1,500. Is that what everyone else got? Okay. Okay to move on? Clear those drawings. And so now in the next part of the problem, we're moving on to a brand new problem. So we're not cover to cover is what we did in the first part. Now we're looking at bibliophiles, and they are a chief competitor of cover to cover. So they're looking at their manufacturing costs, and the first thing we're asked to do is estimate the fixed and variable portion of the total cost using the high-low method. So we have to identify our high point and our low point. So it looks like April is our high point and February is our low point. So we'll be using the same approach that we did in the first part, the high-low method, to separate those. We had talked in class about the concept of relevant range, and I would just say that this company has a very wide range here, from 300 up to 6,800. That's a significant range. Makes me a little concerned about, if this was a real situation, whether this would actually be valid over such a broad range. Once we have the variable cost per unit, we can find our fixed cost by taking the total cost. Again, we can use either one of the high or low points. So I'm going to use the low point because it's just smaller numbers. You'll get the same answer regardless of which point you choose. Oops. Everybody good up to this point? So now we have our formula, and I will write out that formula on the screen. So now we have our formula, which is total cost equals the fixed cost, which is the y-intercept, $250, plus the variable cost per unit times the number of units produced. And so you can use that equation oops. So why does the total cost computed for 4,360 units not match the data for January, where we actually produce that exact same number of units. And the reason is, without reading what they offer there, the reason is we use the high and the low point. We drew a straight line between them as we talked about in class. We drew the scatter plot, and we saw that the actual data is going to be scattered around that line that connects the high and the low point. And so our best answer is probably this one. The high-low method gives a formula for estimating the total cost. We know for sure that the high and low points are right on the line. We can see that here with the 6,800 units. That was our high point, and it exactly matched. But it's not necessarily going to give us an accurate number, a perfect number other than those two. I should also point out, in another month that we produced exactly 6,800 units, our total cost may not match April's cost, but it's a way of estimating. So it's not going to be perfect, it's an estimate. We talked about in class how the high-low method really is not perfect because it doesn't take into account the dispersion around that line of the other points. And that's why using a method like linear regression, which is beyond the scope of this class, but I just want to have you keep that in mind, that would give us an even better line because it takes all of the data points into account rather than just two basically randomly chosen because they're the highest and the lowest. Everybody good up to this point? I'm very aware that we're running short on time. We've got just a few minutes left, so I want to make sure we cover as much as possible in the time that we have. So the next section is on contribution margin. We have the income statements here for cover to cover and bibliophile. I think in the interest of time, I'm just going to talk through these rather than doing all the calculations together. So if you hover, you can see the formulas for contribution margin and for calculating the contribution margin per unit. Each company sold 83,800 units, so that's going to be necessary for calculating the per unit cost, dividing the totals by those number of units. Contribution margin ratio is the contribution margin divided by sales. We know the formula for finding break-even units. We can use that. I can put that on the screen, or you all know that. The break-even formula is fixed cost plus profit, where profit is 0, divided by the contribution margin per unit. And you'll be calculating that right here in the top part of this.
I know we did those equations in class. Are they also in reference materials or no?
I'm not sure.
Okay.
I certainly can put them there, but it won't be until later because I do have, let's see here. They are not in the reference material, so let me make a note and I can put them there. So okay, so I will do that later. Remember, to find break-even sales dollars, you're going to take the units and multiply the selling price. It doesn't tell us the selling price, but you can calculate that because you know total sales and you know how many units they sold. And then we have a sales mix problem. So you're going to let's see what. Where does it tell us? Oh, okay, so we don't even have to calculate the weighted average contribution margin. It tells us what it is right there. So you're going to use that $2.31 in this formula in the denominator. And you'll calculate the total number of units that you would need to sell. You can actually, from that, so we know our, you can calculate from here. Actually, from here, you can calculate the contribution margin per unit. And from that, you can calculate what the weights must be, because it tells you what the weighted contribution margin is. It's actually a bit more complex. So think about the way we calculate that weighted average contribution margin. So some percent of, some percent of basic plus 100 minus whatever that percent is of deluxe. Equals $2.31. And you're going to plug in, where I have basic in this formula, you're going to plug in whatever the contribution margin was for basic that you calculate over here. And then for deluxe, you know, the 90 cents for deluxe, the $3.25 for basic. From that, you'll be able to find these weights. From our result of this formula, plugging in $2.31, you'll be able to find the total number of units, and then you'll be able to use these percentages to split the sales between basic and deluxe. And then in the last part, it asks, what if we want to increase our profit by $40,000? So cover to cover's profit was already $62,850. If we wanted to increase that to $102,850, what would our units be? And the same thing for bibliophile. So we are out of time, unfortunately. I'm going to stop the recording, but if you have additional questions, if you get stuck as you continue working through this on your own, please let me know.